For a long time I've wanted a good wind instrument-based MIDI controller. A few years ago I bought an Artenoise re.corder. I like it and use it, but it's not ideal for me. Before we get to the Haxophone, I'll expand a little on my issues with this. It doesn't have wired USB MIDI, only Bluetooth. This does allow it to connect to the dedicated app and my Mac, but Bluetooth is always a bit of a faff, and there is bad latency in this case, which may be the fault of the Bluetooth, or the instrument itself, or both. If it worked over USB, it could in principle reduce the latency to 0. I'm almost always using it here in the studio and wouldn't mind the cable. Maybe this next point is a configuration issue, but I remember discussing it on forums, so I'm sure it isn't just me. You need to blow quite hard to get a response. I helped this issue by partially blocking the air escape hole, but I still don't particularly enjoy playing it. It just doesn't feel as easy or natural to blow as a real recorder. Another issue is the capacitive touch. The re.corder is also usable as an acoustic instrument, so it needs physical holes, and touch sensitivity around those holes is the only way to go there. Other similar instruments also have touchpads or studs, but those often have the outside sealed from the inside. This type of instrument gets wet, you see. When that happens, it affects the use of these pads, particularly the thumb one. Then it becomes unusable and there's no option but to stand the instrument up and let it dry out. This is an open source project and it looks that way. I don't mind that. In fact, I like the DIY look. I also love that it's, quote, designed to be an inexpensive and fully customizable travel saxophone. It was the first time that I'd seen mechanical keyboard keys and caps used on an instrument like this. This is very appealing. I think the positive action of those will make this more playable than a capacitive touch instrument. Although this is modelled on a sax, I believe that it'll be possible to build one with only the 10 or 11 keys needed for recorder-style fingering, and to add both soprano and alto fingering maps to the software. The designer aimed to keep the cost of this below $100. I was never under any illusions that this would be easy or cheap. You have to buy parts from several different places, often with postage to pay on each order, and sometimes you have to buy multiples for economy or just because you have no choice. Sometimes you make the wrong choices or just order things you don't need. So for the money I've spent so far, I think I could have bought a decent ready-made. However, the DIY aspect and the customization possibilities make that worthwhile for me. Personally, I don't need the audio side. I'd far rather just have MIDI out, which is really flexible and useful. Therefore, I ordered the PCBs without the surface mount assembly, which saves some money. There's a minimum quantity of 5 when ordering from most fabricators. This is fine because I have plans to build some variations. At the same time, I ordered the 3D printed parts. These aren't strictly necessary. You could blow into the flexible tube and manage without the thumb rests, but I like the design of these parts, and I'm not trying to save money here. I don't have a printer, but I do order 3D printed parts regularly for other projects. What I wasn't sure about was what was the best material for these. PCBWay happens to default to default white resin. Choosing that wasn't so much a deliberate decision as simply going along with the default because I didn't know what would be best. As it turns out, I think that it might have been a very happy accident. This is the first time I've handled resin parts, and I really like the feel. They feel more like ceramic than plastic, and I suspect it'll be better for hygiene reasons. It also turns out that the small self-tappers I happened to have will go into this material beautifully and securely without the feeling that anything's going to crack. For the Pi, I've gone with this option, an RP2040 Pi Zero. All the power of a Pi Pico in the size of a Pi Zero, as someone said. It sounds like the worst of both worlds when put like that, but I think this is a great choice. Haxophone software is available for the RP2040, which is Raspberry Pi's microcontroller. This has the advantage of being ready to go as soon as it's powered up. Unlike the full Pi, which is required for the audio version, which takes a minute or two to boot up. This is perfectly capable of receiving the user's input and generating the MIDI. I use that controller all the time in my own instruments. To keep things simple on the Haxophone board, it just has the one standard Raspberry Pi header, and this board fits that. There's a lot more on this device, most of which won't be used here, but could be useful for future projects. Importantly, it has USB-C, which is more robust than the micro USB that the Pi Pico has. I bought the key switches and caps from Amazon, and most of the electronic components and some hardware from Mouser. Naturally, when I started to build, I found that I had missed some parts and have had to place a further Mouser order. Even though I'm not building the audio version and didn't have the surface mounts parts assembled, it turns out that some surface mount parts are needed for basic operation, namely the key switch diodes, some pull-up resistors, and an I2C ADC. I'll have to hand solder those parts, but that's feasible. I've made a start and have ordered the parts that I missed. I have to say that the documentation for this project is excellent. The assembly guide in particular is really well written, comprehensive, and has loads of pictures.